Hi guys, in this lecture we're going to be creating a pattern matching app. So you should already have Vision Assistant open already, okay? So what I want you to do is click on Open Image and then select the 3 pictures in the checkers dataset. Now this will obviously be in the resource section of this course. So go ahead, download it and then open up your dataset. Click Open. So as mentioned in the theory, pattern matching will only work for scale invariant and rotation invariant matches. However, in LabVIEW, we can do rotation invariant matching. So it will scan from left to right and then scan diagonally to find that pattern. So the dataset that we selected are the checkerboards as well as a pattern test. We'll be handling a simple one where basically all of these look more or less the same. If you take a look at this one, they look almost the same, but as you go further away into the board, it becomes scale invariant. So basically the sub-image becomes smaller as you move further away from the bottom of the image. Okay, so let's get started with pattern matching. Okay, so in order to do pattern matching, we first need to make it grayscale, as we normally do. So go to color, plane extraction, and you can extract a certain plane that you feel is good. You can either go for the value plane or for the red plane. Both of them look the same. So click OK. And now we go into machine vision and onto pattern matching. Now in the pattern matching menu, we select new template. And over here, we select a template of the one that we want to match. So let's look at this one here. Just like a particular good match. Just make it so it's just over that shape. Click next. You can edit out this here if you want. It doesn't have to be accurate. Covering this in red basically tells LabVIEW that you should ignore all this in red. Click finish. And then save it as a template. So call it template bead 1. Okay, so as you can see, it detected this one here. Just click on this button so you got the full view of the board. We go to settings and click on around say 20. Now you can see that it doesn't detect all of them, right? So now we need to lower our minimum match score. Let's try 500. Okay, so now it's detecting all that as well as the white squares, which is undesired. So let's increase that. Let's try 620. And there you have it. We are able to detect all of these matches. And if you count them, they are around 9 because we've got 4 over here and 5 over here. And that's ignoring this one over here. Now, if you want to search for rotated patterns, you can select that one. But we will do this in the later part of this lecture. You can also select the different algorithms. Now, the grayscale value pyramid works particularly well, so we'll keep to that. And if you press OK, and then you have detected your patterns. Okay, so if you had to copy and paste one of these into another block, your pattern matching algorithm would be able to detect it, as long as everything remains the same and your sub-image looks similar to the template. So before moving on, I want you to remember the theory that we learned about pattern matching. It can be mainly used in control conditions and the scale invariant and rotation invariant, except in this case for this algorithms. And it's also best used in a control environment. Okay, let's move on to the next dataset. Okay, so here we have our image. We have a lot of beads and we would like to count them. So as you can see, we already have the color extracted. And now we need to adjust our template. Click on new template. And now we want to make the template one of these beads. So we can make it just the inner part of it because we have the beads on black and white plates. And we don't want that to affect our algorithm. So just select that and press next. Click next again and finish. Save it as template bead 2. And as you can see, it works quite well off the bat. And we have detected around 15 of them. but we are also missing these two. Okay, so it seems that we are limited here, so 620 should be enough. Let's try going higher. So you can see it's quite robust at using a minimum match score of 700. So that's basically a 70% detection sensitivity. So basically what this gives us over here is the XY position of each of them. So we got about 17 of them. You can count them up. And if you had to add another one of these beads around here, you'd be able to detect it with pattern matching. So if there was a change in this image with another bead, you'll be able to detect it whenever that changed. Okay, let's move on to our last data set for this lecture. Just click OK. And load this one up. Okay, so we do the same. It is already in grayscale, so now we just select a new template. And say we want to look for a alphabet T. And we want to look for in all orientations. Select next. And then finish. And we call it template T. Now you can see it's detecting a whole lot, so we need to adjust our sensitivity. We also want to search for rotated patterns. So let's just make this 800. Okay, still not good enough. We want to set this to 90 degrees. So it detects that. Now this one is number 4 and 5. Number 4 and 5 has 800 and 812. So let's make this 850. And as you can see, we are able to detect these three, but this one is lying outside. So let's see if we can incorporate that one. I think it's lying about 2 on the outside of that. So let's just focus on the inner ones. So you can see that our pattern matching is able to detect rotation invariant objects within our scene. Let's try another one. Click OK. Now let's try and look for this U-shaped object. Click next and finish. And we're just going to call it U for now. And it detected these two, but not that one. So we just adjust it to 20. Let's see. Now it's detecting way too much. It's too sensitive. Select 180 degrees. Okay, let me make this 850. And there you have it. If we make this image larger, we can detect all 4 of them in this image. Okay, so that's it for pattern matching. Hope you enjoyed this lecture. We have basically learned how to detect objects within a scene using pattern matching. So what are the uses for pattern matching? Well, the reason for using pattern matching is so, say in this particular case, we want to detect a specific region of interest. So we use pattern matching to detect these 4 objects within our scene. And now, as you know, processing an image takes up a lot of resources. So if we limit our region of interest to this small region or these 4 small regions, processing these with regards to thresholding or calculations or caliper or edge detection also, it will greatly minimize the calculation cost or computation cost that is required to process those part of the images. Okay, so in the next lecture, we're going to be doing some object tracking. This is some exciting stuff, and I shall see you in the next lecture.